This is Geometry, Unit 7, working on Day 2, talking about similar polygons. What we're going to learn about today is writing a similarity statement and also about writing a proportionality statement. One thing to recognize the difference between similar polygons and congruent polygons. Two polygons are congruent if their corresponding angles are congruent and their corresponding sides are congruent. We're going to talk about similar polygons. And two polygons are similar polygons if corresponding angles are congruent. So the angles have to be the same, the corresponding ones. But the corresponding sides are going to be proportional. What does proportional mean? That means from the corresponding sides, there has to be some multiple to get to the value. So you have to multiply by 2 to figure out the other sides, like dilations. We have seen those in the past. If two triangles are similar, really if two polygons are similar, then the symbol that we use is a squiggly line. It's it's very similar to the congruent symbol, which would have an equal sign underneath it. This is just a single squiggly line. An altitude. An altitude is a segment that drops straight down from a vertex and is perpendicular to the opposite side. So there are multiple altitudes in a triangle. And notice that these are all going to actually touch in the exact same location. Those are called altitudes. Altitudes don't necessarily touch the midpoint, so it's not a perpendicular bisector. It's just a segment that is perpendicular to the opposite side. An altitude is different than a median. A median goes from a vertex to the midpoint of the opposite side. And there it might not be perpendicular to it. It might not be a perpendicular bisector. It might just be a bisector. That's what a median is doing. It's bisecting the opposite side. And notice that again, they go right through the same location. So an altitude is going to be perpendicular to the opposite side, and a median is going to intersect with the midpoint of the opposite side. How this relates to our similar concept: if two polygons are similar, then the ratio of any two corresponding side lengths in the polygons is equal to the scale factor. So we're going to see that in our first example. So what we're going to do down here, we're looking at two triangles. We see that they're similar. JKL is similar to EFG. So looking at the different segments, we've got the first two letters that correspond with the first two letters, the second two letters correspond with the second two letters, and the first and last with the first and last. We know what sides are supposed to correspond with each other. Just like a congruent statement, this is called a similarity statement. We can see where the corresponding parts are located. What we need to know is, what is the scale factor? We're going to find the scale factor. That's going to help us figure out the median length of Km. So to find out the scale factor, we need to take two corresponding sides that we have measurements from. Well, JM is part of this JL. So this side is 48. So we know that 96 is the total length across. And in this case, this is 40. So we know that 80 is the total distance all the way across. JL is your first and last letter. EG is your first and last letter, so we know that those are considered corresponding because their vertices or their letters, the segments, land in the same location on the similarity statement. So we have JL being compared with EG. So we know that JL is 96 and EG is 80. We can clearly divide that by 2. And we get 48 over 40, which would have been appropriate. We could have used just the 48 and just the 40, but I wanted to be sure you understood that we weren't just taking any numbers that they have and throwing them into a fraction. We needed to be sure that they were corresponding sides, and we were taking the side length. And now we're reducing, but half the side length of each is still proportional. This is divisible by 8. So we have 6 divided by 5. And there's your scale factor. The scale factor is 6 over 5 if we're going from the triangle on the left to the triangle on the right. So now what we need to do is, how is that going to help us figure out Km? Since the scale factor of triangle JKL and triangle EFG is 6 over 5, we know that any corresponding segment will have the same scale factor, 6 over 5. That's pretty much what this statement up here talked about. If two polygons are similar, which we know they are, then the ratio of any two corresponding lengths of the polygon is equal to the scale factor of the similar polygons. So when we look over here, we see that Km is a median, and it's going from letter K, which is your vertex, it's the middle one, and it's corresponding to the median that's going from the same location, the center location, so F. Those two are called corresponding medians. So we know that Km has to be corresponding with FH, and that their ratio has to be the same as the actual triangles. Since Km is the measurement we're looking for, FH is a value of 10, we know their scale factor is 6 over 5. We can cross multiply. I really only have to cross multiply in one direction, 60 divided by 5. If I multiply this way, I'd just be dividing by 5 now. So that makes this 12. So Km is going to be 12. We figured that out by recognizing what the scale factor was, noticing that that had to do with the medians, writing our proportion, and solving our proportion. On the flip side, we're going to be looking at determining if two polygons are similar. To identify if two polygons are similar, we need to know two things. Are the corresponding angles congruent? And are the corresponding sides proportional? That's what makes similar. So we need to identify the corresponding angles. We see that angle B has one tick mark and angle K has one tick mark. So angle B is congruent to angle K. C has two tick marks and L has two tick marks, so angle C is congruent to angle L. 3 and 3, so angle D is congruent to angle M. And then of course right angles, because there's a box in the corner, angle A is congruent to angle J. So what this shows us is that the corresponding angles are congruent. We have 90-degree angles, and then moving to the right we have 1 tickers, and then 2 tickers, and followed by 3 tickers, right back to our 90 degrees. So they're in the same order, they're considered corresponding. Now we have to look at the side lengths. The side lengths, we're looking at the segment that's between the 90 and the 1 ticker, which is AB, and the 90 and the 1 ticker, which is JK. We put in their numbers, their values. It's a length of 8, a length of 14. This can be reduced, and this gives us a scale factor. Now we're not sure what this ratio, I called it a scale factor. It's not the scale factor yet, it's just a ratio. It gives us a ratio, 4/7. We're not sure all of them have to be 4/7 before it becomes a scale factor. So let's go ahead and look at AD. AD is 12, JM is 21. We can divide that by 3 and divide that by 3, and we also get 4/7. So this is looking pretty good. CD is 8, LM is 14. We can divide that by a common value, reduced it, and we got 4/7. So I'm feeling pretty confident that our last one, BC, which is 8/14, those are the same numbers. So when we reduce it, we're going to get 4/7. So that's what we're really paying attention to, is that the ratio of these corresponding sides are reduced to the same fraction. That makes these corresponding sides proportional. So we know that the scale factor from the triangle on the left to the or it's not a triangle but a polygon, quadrilateral, on the left to the right is 4, 2, 7. You do need to be careful on how they have it written. If they switch the order, then we need to be sure to write it 7/4. But because they have the ABC, which is where AB came from, on top of the fraction, and JK is on the bottom, and that's true all the way through, then we have the 4/7 all the way through. Okay, a proportionality statement doesn't have any numbers involved. A proportionality statement would be the corresponding sides that match up. AB corresponds with JK, which is supposed to be equal to AD and JM, which is supposed to be equal to CD and LM, which is supposed to be equal to BC and KL, because they all reduce down to the same fraction. That makes this a proportionality statement. It's kind of like a proportion. It's an extended proportion. We call that a proportionality statement. There's no numbers. It's all the letters. If you can write a proportionality statement, you can definitely write a similarity statement. The first quadrilateral is similar to the second quadrilateral. And what letter went with A? But the J went with the A. And K went with the B. And L went with C. And M went with the D. Notice we don't put a symbol in front. We definitely don't call it a triangle, because it's not a triangle. It's a quadrilateral. It has 4 sides. We don't put a symbol in front of that. We just, this is a polygon or a quadrilateral. ABCD is similar to JKLM. So here we know that we have 2 quadrilaterals, 4 sides, that are similar to each other. We can find our common ratio. If we know they're similar, we don't have to determine if they're similar. Then we don't have to test all the sides. We just got to find 2 sides with the same scale factor, or with numbers. So GF and LM are 2 numbers, 2 sides with numbers. We could even go with another set, but we're going to look at FG, and we're going to compare that with LM. FG and LM. So FG was 15, LM was 12. Well, we know that that's divisible by 3. They're both divisible by 3. So this reduces to 5/4. So you could say that that's your scale factor. But notice how they're asking us to write our scale factor. They're asking us to write our scale factor LMNP to FGHJ. They want us to write it in the opposite order. They want us to write it with the J, with the LM on top and the FG on bottom. So that's actually telling us to write it as 5/4. So watch the way they ask you to write your scale factor. Very important. Alright, so now we have our unknown here. Our unknown value comes from MN. And that corresponds, we can even look up here, MN is the middle 2 letters, GH is the middle 2 letters, and that should have the same scale factor. You need to be sure you write the fraction correctly. MN came from the fraction on top, GH came from the fraction on bottom, the denominator. So we have our value we're trying to find, and we have our value we know. When we cross multiply, I only have to cross multiply one direction, because if I was to cross multiply my 5 up, I'd have to divide it right back under. So that is, this should just be, sorry, this should be 4, not 40. This is 4 over 5. So 40 times 4 is 160 over 5, and that reduces to 32. So MN is 32. How did we do that? Well, we looked to try to calculate our scale factor. We wrote our official scale factor in the order that they requested us to. If they don't specifically tell you, then it's up to you to keep your problem in that same format. And we're going to find the value of x, which is our value of mn. We plug in the numbers we know, we cross multiply, and we solve. Have fun.